Hey everyone, so today I'm going to chat about democratizing world's compute. First of all, what's compute? Compute is basically like any logic that is getting executed. Like by definition, it needs to have an input and an expected output. And like you always need to get to the same output. Ultimately, this allows us to slowly get to intelligence. Basically, compute allows us to unlock intelligence because we are doing a particular algorithm all over again. Why it's important that we democratize intelligence? Because by doing that, like we are basically allowing like every human being to have like amplified impact on this planet. And if you look at today's economies, like they are basically capped by the amount of people. So like how many people are actually living in a particular jurisdiction, whether that's China or the US. But GDP is per capita, not independently from the capita, and kind of focus more on the energy side of things. And by basically allowing everyone to access intelligence, we are disrupting that paradigm and basically allowing economies to have like infinite impact. Now, what's the state of compute today? So basically today it's pretty bad. It kind of came from a place where people needed web servers. And usually when you would get a web server, you would never get a small web server. You would get a server. That server would have a few hard drives. And then you had a website that was a few kilobytes. And over time, what people understood is we don't need like big servers for a few websites here and there. And basically what happened is that everyone decided that instead of doing that, what we want to do is we want to share these servers between like multiple entities. And that's how you got to hosting companies and so on. Ultimately, at some point, hosting companies were not sophisticated enough to the point where like web apps and like more sophisticated abstractions could have been run at hosting companies. This happened with PHP and so on, but ultimately it was not sophisticated enough to the point where it was enough for that particular development of the compute ecosystem. Then what happened is that AWS, Amazon, actually before that, they realized that they have a bunch of these servers because usually they need to over-provision the servers so that when more people are buying books and stuff like on Amazon, that they could basically rent particular parts while they are not actually overbooked. And that's how AWS became to be. And what they did is they had to figure out ways of basically dividing these resources between multiple tenants. Basically, we have one big server and you want to divide it between multiple tenants. And that happened for hosting as well, for storage in there. Now, ultimately, where we are today. We are today at the point where AWS and Google Cloud, Oracle and so on, they are basically 4 or 5 companies owning 70% of the market. And that's not solely the issue. The issue is that also by owning 70% of the market, they are also trying to artificially keep prices high and kind of not allow anyone to get into that market. And ultimately, you don't see DigitalOcean here, you don't see a bunch of others, because it's very hard to get in that market. And then back in the days, 4 or 5 years ago, I started asking my question, why is it so hard to get into that market? And ultimately, you get to the point where you understand that the tooling is completely centralized. So if you want to use AWS, you'll never use a VM on AWS. You'll use Lambda, you'll use a managed DB, you'll use a bunch of tooling that was built on top of these VMs, these abstractions that used to be basically the resource that everyone would want to buy. And ultimately what this ended up causing is that basically we all depended on these tools, and they realized that they want to lock you in, and then the pricing was also adjusted in that context. So for example, if you want to read something from AWS, it's going to cost you an insane amount of money. For example, a JBOD that is this big and has 1 petabyte, if you want to read that, you'll pay $500,000. And that JBOD costs $40,000. So ultimately, this pricing and these abstractions got us in a very weird spot where everyone keeps everything inside the cloud, and ultimately that caused that we have a 70% market penetration for a few companies that are entirely run by profits and so on. Now, going back to compute. So ultimately, to get to compute and with that to unlock intelligence, we need two things. One thing is we need to store data, and we need to be able to like remember things for a very long amount of time. And the second one is we need to do the logic. Compute is a very abstract term that usually people connect to like, oh, is it a GPU, is it a CPU? No, ultimately compute is not either one of them. Like compute is just a job. You need to do a function that has an input and an expected output, and there is a way to verify that the output is actually like the execution of that function. Now, why is this important? Because ultimately, it gets us to the point where, yeah, like let me go back. Like I want to grab something. Ultimately, it gets us to a point where compute is basically just converting energy into like some execution of some logic, and like it doesn't have anything to do with how that execution is done. Now, there is a big demand for converting like this basically energy into the execution of like a particular logic, because again, ultimately it allows us to get intelligence. And like if you look at all the investments that are happening today, of course there is a bit of a bullish market, but like the reason why all of this is done is in fact the fact that by investing in like intelligence, you're able to decouple the economy from like the market cap per capita, in the sense that it doesn't matter how many people you have living in a particular jurisdiction. The only thing that matters is how much energy are you able to procure, and how are you able to actually convert that energy into intelligence or computation. Now, that's one part of the story, but the issue is, unfortunately, this is a PDF, so like the globe is not turning. But the issue is that like ultimately energy is uniformly distributed. Like no matter how much effort we put into building a building like this, which is super big, like and has like multiple like areas for energy conservation, for example, generators, a lot of energy production with the solar panels and so on. Ultimately, it's not enough, because what we are doing is we are trying to scale vertically, and scaling vertically that doesn't last forever, because ultimately you're running into physical problems, which is there is just not enough energy around you. Right now, we are getting to that problem. We are not yet there. So if you think about like what's the biggest deployment of AI today, that's Grok, Elon Musk with his team. And ultimately what they are doing today is they have a bunch of generators on all the time. So like they're basically producing energy by burning fossil fuels with generators, pumping that energy into batteries. The batteries kind of like cleaning out that energy, because like when you run like a combustion engine, like the electricity is not as clean as you need for a nice GPU from NVIDIA. And ultimately, that's what's happening today. So like we have yet to hit that constraint, but we are very close, because they run out of energy completely. It's not about space, it's completely about energy. And again, it's not about GPUs. GPUs are going to become more available, ultimately because there is competition coming in like from EMD, like a bunch of other specialized silicon producers, but ultimately it's an energy problem. So yeah, like you can see that like there is so much energy around the planet, but what we are doing is centralizing the compute in particular areas. And like if I had to like pinpoint like a particular building like this, in this chart, you would not even see it. So like what we need to do is we need to figure out ways of building many factories like this, which are basically acting as data centers, that allow us to convert like energy into like computation efficiently. And it cannot be centralized, unfortunately. So like that's a very hard or almost impossible job for like the big corporations to solve, because they need to kind of enable big parts of the population to actually like work on that. Now, ultimately, it ends up being a very simple problem. So how do we unify every available piece of silicon, regardless of the location, the ownership, into a seamless shared resource pool? So what this means is, how do we get to a point where we are able to get like storage from everyone that has like storage, enable like small SMEs or like larger companies in particular jurisdictions. For example, in Serbia, how do we enable Telecom Serbia to like provide resources for this big network? Because ultimately, governments will want to like allocate resources into like intelligence, but like what's again missing is that tooling that needs to be built. Now that tooling is coming in the context of decentralized compute and storage, also called DPIN, the PIN standing for physical infrastructure, and it's coming in like different forms that kind of reassemble the products that we had on decentralized clouds. If you think about AWS Lambdas, that's something that Fluence is doing today, basically allowing people to execute functions and execute particular workloads in the form of a function, simple Lambda function. Jensen is allowing everyone to train like neural networks or LLMs that are at the size of GPT-3, for example, today. And the tech is getting there. So like ultimately you couldn't build that tech by yourself 2 years ago, but now like that tech is becoming more and more available. And then you have like, of course, Snark, encoding and rendering, like all of these are like great use cases that are coming today. Now, what's happening is that these networks are doing one thing. Like one is building the tooling, so basically allowing everyone to access the same tooling no matter what data center or compute provider it is. And the second one is they are basically defining a particular job and linking a particular incentive toward that job. So for example, in the context of Fluence, one function needs to be executed. And you're able to verify that that function was executed. And when that happens, you're basically incentivizing the provider of the resource with a particular incentive, which can be like in the native Fluence token, or it can be like in stablecoins. But that part is super important because like ultimately you realize that at the end of the day, like it's logic that is being incentivized and people having like a different ways of executing that logic and getting the incentive. And ultimately what we get is we get an open economy for compute because you're able to look at a particular market, you're able to know how to execute a particular job, and you're able to execute the job and you know in advance how much you're going to earn. This allows everyone to focus on, for example, optimization work, which has seen like a tremendous need in AI, for example, today. Like why DeepSeek is 20x more efficient? Because there is no market for optimizations. It's just big companies being able to raise infinite amounts of money and buy like GPUs from the biggest GPU manufacturer on the planet. But no one is thinking about the optimization, even though like there is obviously space for optimization, at least 20x, because 20x is already something that we've seen. And when you open the market and you allow basically people to look at a particular number, know how much they are making, and see that they can be making more by optimizing a particular job, that's what actually gets us in the area of where like we're able to optimize the cost from 20x to 50x. Also something super important that we kind of take for granted is the economic flywheel that this enables. Because today, if you want to do anything on the cloud, in fact, like a couple of days ago, I tried to like open up a new DigitalOcean account for a small project, and I didn't have permissions to open a team. I can't add people to my team because I need to open a ticket for that. And I need to ask someone with a whatever, like computer to accept me to like have a team. If I want a GPU, I need to ask for one GPU. Like ultimately, this is not an open market. This is a completely kind of like gate-capped market that like you can only access in particular circumstances, and it also kind of like locks out of this like a big majority of the planet. For example, if I was from Africa, it's really questionable whether I could use those tools because like probably my credit card from Africa would not go through, or do I even have a credit card in Africa or China? Like all of these tools are kind of locking us out of like this open economy that we all thought we could have and we should have. Now, I'll quickly go through like a few examples of something that worked already and that have basically shown that like doing things like this is possible, and that's Filecoin. So Filecoin today has 8 exabytes of storage capacity. If you try to visualize 8 exabytes, it's basically this room times probably 50 full of hard drives. So a hard drive is like this big, and the hard drive like allows you to store 24 terabytes. This room times at least 20 to 50 is basically 8 exabytes. And someone is powering that, someone is maintaining that. When a hard drive breaks, someone is changing the hard drive, and it's storing there. That's happening today. There are 3,000 storage providers participating in this network, so it's not like one big company basically like storing everything. And it's storing some of the most valuable data sets on the planet, like a bunch of the open data sets, a bunch of the data sets from war victims and things that should never be forgotten. Now, all of this is great, and like it really showed that like it's possible to create like an ecosystem like this, but there are a bunch of problems. Otherwise, like we would all be using Filecoin today. And those problems are the fact that Filecoin was built like in 2016, 17, and back then like ZK technologies were not as mature. So ultimately, what Filecoin is great for today is archival. It's not great for hot because like there is no way of like validating that something is on chain in a hot manner. Probably data availability layers are a better fit for that, not snarks. And the tooling is not great. So if you want to move your Web 2 project to Filecoin, like there is no way of doing that. Like you need to learn Filecoin from scratch. You need to understand like all the small pieces. You need to abstract Filecoin with tooling that makes sense for your use case. And you end up building Filecoin tooling instead of building like your use case. And actually that's how I got into Filecoin. Like, by the way, I was part of the Filecoin core team. I joined Protocol Labs to fix the protocol so I could build something else. And I'm still building Filecoin infrastructure today. So it's a hard problem to solve. Like ultimately, it takes a lot of infrastructure work to actually get to the bottom of it. And there is also a part on the economics where like in order for you to participate in the Filecoin network, you need to put a collateral. You need to economically be part of that network and like basically risk that capital if your storage provider or service that you're trying to provide goes offline. So ultimately, the issue with Filecoin, actually the issues that Filecoin had along the way, which are kind of disappearing because a lot of the tooling that we have built and the rest of the ecosystem have built have actually tackled some of this. But like we are seeing the same issues in Deepin, which is lack of tooling. No one is actually thinking about like how the developer is gonna use the tool. Rather, they are thinking in a very abstract way about like the problem that they want to solve. There are a bunch of resources kind of sparse around the globe because no one is thinking about locality. And ultimately, if you want to store something or if you want to run a compute job, you really care where that server is. If you get a Filecoin miner, like there is no way on chain to know whether it's in China or anyone else. And that's really hard because like ultimately it's a lot of cost to move like that much data somewhere, and like you really need to like be conscious of that. Often like providers are not reliable in the context that you need to get. So for example, maybe it takes like 2 seconds to store a video and you need it instantaneously. And maybe there is no reason why it takes 2 seconds, but like ultimately that provider is just a bit slower and you don't have formal ways of like verifying whether that happened in 2 seconds or not. And of course, it's really capital intensive. So like you need to invest tokens and you need to invest hardware in order for you to be able to participate in that, let alone like the technical expertise that you need in order to just run the thing. Now, if you think about what's going on, because like obviously like it's working, like Deepin is a thing today, like after what, 5, 6, 7 years of working on that. What's going on is that right now we find ourselves in a phase where the incentives are super strong, and everyone is trying to over-incentivize like the ecosystem to solve like all the problems that I just mentioned. So for example, if you mine Ether, if you mine like what was the other, like bit tensor, like the incentives are super strong. Like there is 100% inflation happening every year, which basically means that like every year, like double the tokens exist for protocols that are 2-3 billion like valued, which basically means there are $2 billion of incentives kind of like distributed every year for a particular protocol. And like there are these curves where like one curve is basically like the incentives that you're able to draw the problem, and the second one is like the PMF that we were able to hit for the non-product people. PMF is like product market fit. And basically we find ourselves at the beginning in DePIN. And maybe Filecoin is a bit further out, but like ultimately most of the networks are at the very beginning. Now, why is all of this super important? Because ultimately, if we manage to do all of this, what we've done is basically we created a super efficient economy that is able to incentivize the execution of a particular thing. And if you think about Bitcoin, Bitcoin is the largest compute network in existence today. Like it's doing a very stupid job, just SHA-256, but it's doing a lot of SHA-256. And probably like the largest amount of executions of a particular functions in the world. Like, and it's a relatively complex function. It's a stupid function, but like SHA-256 takes a bunch of clocks. Sure, it's hardware optimized, but like ultimately it takes a lot of logic that is done in the background. Now, the issue is, of course, that it does just that, nothing else. And ultimately, because of that, it's semi-useless other than the fact that it has consensus power. So how do we get to the Bitcoin moment with DePIN? Ultimately, it goes back to like building the tooling, because we really need to make it simple. Because if I'm able to plug in a computer in the wall and get some rewards, that's how we get to basically like reducing the cost and increasing the capacity. So I'll be wrapping up in a few minutes. I see anxiety in the room. One last thing. So I'm building Ramo, which is basically abstracting away like a bunch of this complexity around DePIN networks in a way where for compute providers it's like mining Bitcoin, which is I put a computer in the wall and like it gets me some tokens. And for folks that want to use the service, it's basically like the cloud. For example, if you want to store data with us, you just use the S3 API and you change a URL. Basically, like everything else is the same. So you don't even realize that you're using decentralized technologies. I'll skip this because I want to be conscious of time. But ultimately, on one side, you have like capital coming in, providers getting that capital, and that enabling a particular utility on each of these DePIN networks. If you want to use our tools, like just go to the following websites. One is ramo.computer, and one is staking. But staking is kind of closed right now, so like don't go to this other page. But yeah, it was great chatting here. Last quick thing, we've already onboarded $200 million of liquidity and 600 petabytes of capacity. So DePIN is working, like it's useful, but like ultimately it takes a lot of infrastructure. So anyone that is technical, I invite them to do a bunch of DePIN stuff. Like there are a bunch of problems to be solved. Ultimately, we are trying to disrupt how the cloud works. And I'll wrap up with that. Thank you so much.
Okay, guys, we have time for one question. So, yeah, here you go. Stan from V3V Ventures, here you go.
Thank you very much for the presentation. So I just wanted to ask you one thing. What's your view on decentralized compute versus centralized compute, in a sense that decentralized compute has some advantages like scalability, fault tolerance, and so on, but centralized compute, that comes at a cost of latency. So centralized compute is superior in terms of latency. So I feel like both of them can coexist depending on the specific applications that are needed. So I just wanted to hear your view on that.
Yeah. I think there are two parts to the answer. One is, I would say that most compute on the planet is not really latency sensitive, although the way that we do it is very latency sensitive, in the sense that if you want to train a LLM, it's very sensitive to the latency only because we built the abstractions to run in local networks rather than have them run like in open networks with like being fine with waiting hours for something to execute. That's one part. There are a bunch of use cases that are like latency sensitive, and even those are getting like moved into decentralization today. For example, TikTok like is storing a lot of data on like IPFS kind of networks. So like ultimately, what they realized is that they are paying a lot of fees to their ISPs, and they are trying to reduce that by basically using providers like closer to the users. So a lot of the content that you see on TikTok is actually not stored on TikTok servers. It's stored by Falcon storage providers, which, by the way, are not running Falcon for TikTok because like it's impossible because it's too slow, but they are doing Falcon and TikTok. Now, there is opportunity for someone to formalize that. Why is there no like no way of like storing it on chain with low latency? Because these problems are hard to solve. Like it requires you to know data availability. It requires you to understand like the proofs. It requires you to have some consensus. Like it's hard to build, but like ultimately, the PMF is there. Like it's just that we, as the crypto ecosystem, have just not like been good enough at building these products, and there is obviously like a lack of talent. Like there are no good people in crypto anymore, which you probably realize as a VC. But
Thanks for the answer.